So, the question myself and Megan had was the FRQ number 14, and the question asked us to suppose that a stable element with atomic number 119, symbol Q, has been discovered. And the first question that was asked was the first part of the question that was asked was to write the ground state electron configuration for Q using noble gas notation. We figured that it would be OG8S1 because the last noble gas on the periodic table is OG, which is oganesson. And by noble gas notation, you should put those in brackets, and then the next S row would be 8, the leftmost row, and so you put 8S1. The second question would Q be a metal or a non-metal? We figured that it would be a metal because it is in group 1, which is made up of alkali metals. And the third question that was asked was, would Q have the largest atomic radius in its group or the smallest? Would Q have the largest atomic radius in its period or the smallest? We figured that Q would have the largest atomic radius in its group because it has the most energy levels of all the elements in its group, and Q would have the largest atomic radius in its period because all of the elements in the period would have the same number of energy levels, but Q has the fewest electrons of all the elements in its period, so there's less attraction towards the nucleus, pulling the shells closer to the nucleus. The fourth question is, what would be the most likely charge of the natural Q ion? We say it would be +1 because Q has one valence electron in the 8s shell, so it is more likely to lose that one electron to have a full valence shell than to gain 7 electrons. The next question was to write a balanced reaction of solid element Q with water. We said it would be 2H2O liquid plus 2Q solid would get us 2QOH aqueous plus H2G. And we figured, so you're reacting Q with water, and you know the left side of the equation is going to be Q plus H2O. Then it's going to turn into Q. It's going to turn into Q hydroxide and hydrogen gas, which is H2. And to balance the equation, you know you have 2 hydrogens on the left side, but on the right side, you must have 3. So if you put a 2 in front of the QOH, you will have 4 hydrogens on the right, 2 Qs and 2 oxygens. And on the left, you have 2 hydrogens, 2 oxygens, and 1 Q. To balance this, now all you have to do is put a 2 in front of the H2O and the Q on the left. And there you go. The next question was to write a formula for the compound formed between Q and the carbonate ion CO32 negative, and we figured it was Q2CO3, and this is because Q will form a +1 ion, and we know that CO3 has a 2 minus charge. Then all you have to do is, knowing that there are 2 Qs for every 1 molecule of CO3, you get Q2CO3. And then the last question asked if there should be a Q carbonate compound or whether it's soluble in water. We said it'd be yes, because with salts that contain these types of ions, the attraction between the positive ion, the alkali metal ion, and the negatively charged ion is weak enough for water molecules to be able to separate, and therefore allowing the compound to be soluble. Thank you.